angle beam calibration, doing a contact test using the IIW Type 1 reference block. This is the IIW Type 1 block. Today I'm using an Epic 1000i from Olympus. I'm using a AWS wedge 45 degree angle, 2.25 megahertz transducer, and the IIW Type 1 block. Now with the IIW Type 1 block, here's our zero marking machine on the block. We will have a 4-inch radius, and then we will get a 10-inch radius. Oh, pardon me, a 9-inch radius. Sorry about that. A 4 and a 9-inch reflector. The reason I say 10 inches, I set my range at 10 inches. My sound path, I want to set it 10 inches so that I can encompass both the 4 and the 9-inch radius that I will get with the IIW Type 1 block. And we always want to make sure that we put coupling between our transducer and our wedge so that we will get the energy into the part. Like I said, I set my range at 10 inches for the Type 1 IIW block. And the velocity, I set it at 0.128 inches per microsecond, which is your standard carbon steel, mild steel shear velocity. The zero is set at 0. I'm going to let my AutoCal take care of the zero in the wedge. And remember our receiver and our pulsar. We want to make sure that we set our pulsar at 2.25 megahertz. In the case of the Olympus, 2.27 megahertz. But we always want to make sure that our frequency is set matches our transducer. Receiver, I have filtering, standard filtering, and full wave rectification, and my filter is set at 0.5 to 4 megahertz, kind of in the middle. The 2.25 will fall right in the middle. And our trig function, I set my angle at 45 degrees because that's what my wedge is, and in this calibration process we will measure our angle. So let's begin by coupling the transducer to the IIW block. It's coupled up. I see 2 reflectors. Let me take some gain down. Reduce by dB. That is my 4-inch radius. That is my 9-inch radius. What I want to do is I want to find my beam index point. So I'm going to take out some energy here. Reduce by dB. I'm going to hit my peak memory. And I'm going to move my transducer back and forth. And we will see right there, I'm in the middle of my curve of my traced peak memory. That is the maximum energy I'm getting back. That's the sweet spot where this transducer, where this wedge works with this block. And what I have, there's a zero mark machined on this machined IIW block. I will transfer that zero mark to a piece of masking tape that I have on my wedge, and that marks the beam index point of this wedge. So to calibrate, I want to take my gate, move my gate over to capture that 4-inch radius. I want to do second function auto 80, take it 8% full screen height. I want to press F5, which is my auto cal button, and I'm going to, cal mode is sound path, and it has cal velocity and cal 0. The first thing I want to do is cal 0, press that button, and I have to tell the tester that it is looking at, in the gate is captured a 4-inch sound path. So I change that to 4 inches, and here we go. 4 inches. Hit the check button. I can hit it here or here. it will store that value. Now I want to move my gate over, and as you can see, there's a dialog box over here. During calibration, it will say CAL. When I'm done calibrating, that CAL will go away. Let me move the gate over. Oh, sorry. That's my gain. Let me hit the gate. Move the gate over to hover over that 9-inch radius. Second auto 80. Take the 8% full screen height. Now I'll press P2, which is my cal velocity. And I have to tell the machine that it is looking at a 9-inch sound path. Whoops. 9 inches. And by hitting the check, it is calculating. Calibration is done. You see the cal has disappeared. Let me take my gate and slide it over that 9-inch radius. My sound path is 9 inches. Come over and capture the 4-inch reflector. Take that to auto 80, and it reads 4 inches. So at this point, I'm calibrated. I have my beam index point marked down here. Now the next thing I want to do is let's measure the angle, the actual angle of my transducer. And on the IIW Type 1 block, we have a scale here that goes from 35 degrees to 65 degrees on this side. And on the other side, there is a 70 to 80 degree, and on this particular block there's a 60 degree to 75 degree. So there's several ways that you can measure the angle, but since I'm using a 45 degree transducer, I'm going to couple it, and right here on the scale I have from 35 degrees to 65 degrees. I'm going to put my transducer basically in the 45 degree area, and what it is doing, it is shooting that sound at 45 degrees is coming down to this radius here in this large hole. And what happens, we want to you can see a reflector. I want to hit my peak memory, and I want to again move back and forth and find where is my maximum energy. Right here. I'm in the middle of my curve right there. I turn off the peak memory, and so at that point that is where the maximum energy is coming back to my transducer. I want to look at the beam index point that I marked on my wedge, compare it to the scale. In this case, it reads with this block, looks like about 44.5 degree. So what we want to do with that information, my actual wedge is 44.5 degrees. I want to come to my trig function. I want to put in the angle to from 45 degrees to 44.5 degrees. So what that will do, that will give me a very accurate calculation on my trig functions. And then again, of course, when you're doing an inspection, you'll want to, in your trig function, you want to put the thickness of your part in. That way you'll get all the correct information. Last thing I want to do is, again, show how we set the reference. And on the IIW Type 1 block, we have a 60 thousandths diameter through hole that is 0.6 inches below the surface. That is used to set our reference sensitivity. Now, let me change my range down to 2 inches, because 10 inches is far too much. And let me take this down here to 2 inches. And she is going very slow today. I don't know why. There, come on. And my, oops, let me see. No. My range is on the coarse setting. It just is slow. So I just have to be a little bit patient. Because I'm going to set the range to 2 inches. Because I want to use as much of the screen as I possibly can. And normally I don't know why it is so slow to respond, but for some reason this particular tester is in very slow mode today. And like I said, I am in a coarse setting. Alright, good grief. Half hour later, I'm at 2.5 inches. Let's stick with that just for simplicity's sake. So, I can see, like, put a little bit more gain in here. I can see this signal. There's that hole. There's that side drill hole. Let me take my gate and bring my gate over to capture that. Oops. There we are. Let me take that to auto 80. And let's look at the peak memory. And I want to peek this out. Again, that's a reflector from the side drilled hole. That's 0.6 inches deep. And there it is. That's my reference point. Now, typically in AWS, change the gain. Typically, it's 40 to 60, I believe, according to code. 40 to 60% full screen height. For your reference level, I just set my full screen height at 60. That is my reference level. 60 degree full screen height, 58.5 dB to get that much energy back from this hole. So that is the typical reference level. Now, depending on your code, the AWS code will tell you how much dB, because we always scan hot, meaning we always add dB. We want to pick up small reflectors, but then we want to come back to our reference gain in order to do evaluation to see how does our indication or our defect, how does it compare to the energy we're getting back from this reference hole. So that concludes the calibration and the reference sensitivity using the IIW Type 1 reference block with a 4 and a 9 inch radius.